Thank you, Mr. Toastmaster, General Evaluator, and fellow Toastmasters. Tonight I have a promise for you. I promise that if you give me 30 seconds to 1 minute of the nerdiest math computer thinking you can put forth, you may be able to get out a different way of looking at patterns all around you. So, allow me to introduce what I will talk about. Simple to complex. A very simple mathematical equation can make different types of patterns that you'll quickly review and see. So if I can explain it, I'm a computer guy. I program computers, which means I go in a step-to-step approach. Basically, it's like creating a recipe to bake a cake. If the temperature is 300 degrees, turn it down to 400, or turn it up to 400, something like that. So it's a very step-by-step procedure. So I'll keep this tech talk to a minimum as I go. So what does this mean? Well, sometimes when you write a program, you can have the program call itself back to the beginning. So to show you here, can everyone read this? Mm-hmm. Good enough? Okay, so say who remembers the factorial thing from accounting or math? So it's basically 8 factorial is 8 times 7 times 6 times 5. It's basically a decreasing set of numbers all multiplied together. So if you were going to run this particular program using the 2 as the one you're going to run with, if you're not at 1, run the program again, but take 1 away. So it's basically, so this would be 2 times 2 minus 1 is 1. And basically, so if you ran this program with the number 2, you get the result of 2. If it's 1, you're done. If not, go the next one down. Same thing here. For 3, you would try it with 3, nope. Try it with 2, nope. Try it with 1. Okay, you got to the end, you work your way back out, and it'll give you the correct response. This is the basics of fractals, which are geometric shapes. And when you have a program that calls itself, you can see this is only 2 lines of code. It's very, very simple, but it can allow for a lot of different things. In this case, it allows you can instantly calculate 9 factorial, as it'll automatically generate all this without it. It's a very, very little amount of code that can do a lot of great things. That's the whole part of simple to complex. 2 lines of code, a lot of different things. Now, I'm not going to go into this one, but you can see there's essentially 2 loops here. But what does this do? This can make one of the most famous fractal shapes ever. It's called a Mandelbrot. And this should zoom in if the things. But basically, if you look at here, you can see the 2 loops, 2 giant loops. And all around here, you can see miniature loops, and so on and so forth. I wonder if I can get this to animate. Okay, but anyway, do you see how one simple line of code from before, if you keep zooming in over and over and over, you will see the same pattern repeating over and over and over. For another one, to make a simple snowflake, start with a triangle, and then from each point of the triangle, put in another triangle. So this one, yeah, should animate. Let me just show you really quickly that one. And I'll come back to this. But basically, a little bit of code, a lot of complicated patterns. And you can see how one simple thing, this is basically one giant shape with lots of the same shape all around the outside, going into more and more extravagant detail. This is a snowflake that was actually taken a picture of, as was this one, which is very similar, where you have a normal 6-pointed thing in the middle, and it expands out to the buds. One of the most common ones is the Fibonacci sequence, which is really simple, again, only 2 lines. And all you do is add together the number before it. So 0 and 1 makes 1. 1 and 1 makes 2. 1 and 2 makes 3. 2, 3, 5, so on and so forth. It's a very simple formula which gives some specific numbers. Now, why are these numbers important? Well, I'll show you. If you were going to make a box out of these numbers, you'd have 1, and then you'd have a rectangle based off of the square. And you'd have another rectangle based off of that square. And you'd have another rectangle based on that square. Another rectangle, and so on and so forth. So it grows from previous square to rectangle as you add in each number. You can see here this is a 5 by 5 square, 8 by 8, and so on and so forth. So is this making sense? I hope so, because I'm going to show you why this is important. If you were to draw a spiral through it, it would kind of show up like this, where if you go through the curve on the outside of each square, it'll make a spiral with a very specific change in size over time. Now you can see this is called the golden spiral. The human eye and all throughout nature really likes this pattern. It's very common, it happens a lot. For example, this is from a Nautilus shell, where you can actually see how close it is to an approximation of that same equation. Okay, and I should move forward. And cauliflower, very simple thing, very common everyday food. You can still see that as it buds out, goes bigger and bigger flowers in the same spiral pattern. This just happens to have 6 of them instead of 1, like the shell did. Pine cones, the same similar outward spiral approach. You can see, I made it kind of clear here, but you can still see the red spiral, the purple, all these kind of interlock to form the pine cone that you see there. This is another cauliflower form. You can see how one simple little bud can grow in many different directions and have a very complicated pattern. To show you and compare, this is what a person did with a 3D generator with a very simple calculation. You can see the exact same buds here that he generated as in real life cauliflower. So you can see the math is all there. Sunflowers exhibit this too. When you go away from the center of the flower, it's in the same spiraling pattern. Sometimes you can even see it in hurricanes too. So you can notice the shape of both the wind and the temperature and the pressure sometimes form that same spiral shape. And to even magnify out one more time, certain galaxies also have the same exact spiral shape. So to summarize, all it took was a simple little bit of math to go, what was the last thing I did? And you can extrapolate it and find wonderful detail on the most amazing things in all of life. Mr. Toastmaster.